Okay, this is Chapter 3, Practice Expressions, pages 129 to 131, 1 through 26, and page 138, 1 through 20. I'm going through these for you so that you make sure you understand how to do them, not for you just to copy answers. It's really important that you really try these and try to figure them out, and maybe an explanation will help you a little bit more too. All right, here we go. Page 129. Okay, here we go. Consider, number 1, consider the algebraic expression 3x plus 4 and state the following. How many terms are there? Well, there's 1 and 2. 2 terms. The coefficient. Remember, co means with. You're with something. It's the number that's with the variable. So the number that's with the variable right here is 3. What's the constant? The constant is the number that stands alone. It's just representing a number. So that would just be 4. And the operational symbol right there, the operation between the two terms is addition. All right, that was easy enough. Now this table, it says complete the table, and it's substituting for variables. It's telling you that these are the x's. And so x plus 9, that would be 0 plus 9 is 9. This would be 2 plus 9 is 11. And this would be negative 1 plus 9, which would be 8. And this one would be 7 plus 9, which would be 16. This here would be 7 times, when the number's right next to a variable, that would be multiplication. So this would be 7 times, let me be darker here, 7 times 0, 0. 7 times 2, 14. 7 times negative 1, negative 7. 7 times 7, 49. Okay, this next one has 2 parts to it. It would mean 5 times x minus 2. So you're just doing a couple parts to this. So 5 times 0 is 0, minus 2 will be negative 2. 5 times 2 is 10, minus 2 is 8. 5 times negative 1 is negative 5, minus 2 would be negative 7. Negative 5 and a negative 2. And then 5 times 7 is 35, minus 2, 33. So those would be your answers for that. Okay, state whether each expression can be simplified and explain why. Well, can this be simplified? I have 2k plus a k. Can I combine those together? Yes, because they're both k's. So yes, because they have like terms. Can this be simplified? Well, a u can't go with a w, and a w can't go with a 1, so none of these are like terms. So can this be simplified? No. No like terms. How about this one? 7x can't go with a 3 and it can't combine with a y. So nothing can combine, so this is no like terms. 4g can combine with a negative 3g, which can combine with a negative g. So now you just look at this. What's 4 minus 3, which is 1, minus 1 is 0. Can it be combined? Yes, because they have like terms. All right, now let's look at this one. This one we're actually going to simplify the expressions. So, can I put the t with anything? No. But can I put a negative or a positive 1 with a positive 6? Yes, 1 plus 6 is 7. So your final simplified expression would be 4t, and that's a positive 7, plus 7. 4t plus 7. Final simplified form. And this one, I could put a 4y together with a 5y, which would give me a 9y. I can't combine it with this constant, this positive 3 or plus 3, so that would be your final simplified expression. Oops, sorry. Over here. Oh, 5p. A 5p minus a 5p. Those cancel out and you have nothing. That was easy. A 4m minus a 3m can be combined, and this constant stands alone. So what's 4 minus 3? 1m minus 3. That would be correct. But you could simplify it further because you don't have to write this 1. Because an m, if there's an m there, we know that it's 1m. So the final simplified is just m minus 3. Now we're going to expand each expression, expanding by distributing. Okay. So I go, this means 4 groups of h plus 2. So I could go h plus 2, h plus 2, h plus 2, h plus 2. But this is a lot of work. This is kind of a pain in the butt to write. But there's 4 h's plus 2, 4, 6, 8. Plus 8. That's 4 groups. See how there's 4? 1, 2, 3, 4. That would be the, if I was really thinking it out, that's how I would solve that. But I know how to distribute. I'll go 4 times h is 4h plus 4 times 2, which is 8. So there's your multiplication way to distribute. 3 times 4, 12x, minus 3 times 11, 33. That's how you distribute it to expand it. Or I could do 3 groups of this. This will give me 12x and a negative. I add all those 11s together, negative 33. So that's how you would do it that way. Look at these ones over here. 5 times 4, 20, plus 5 times 5c, 25c. But that's not written in proper standard form. I'd have to put the positive 25c first, and I just write it as 25c, and that's a positive 20, so plus 20. Final simplified expression. This one here, 7 times 3, 21, minus 7 times 5, 35p. But to put it in proper form, I'll put that negative 35 first. So sometimes that negative is a minus sign, and sometimes that negative is a subtraction sign. In this case, I'm going to use it as a negative sign. That's a positive 21. So plus 21. Done there. Okay, so we finished the first page of the problems. Let's go to the next. Okay, now we're going to factor. I don't know why this isn't turning. Oh boy. Okay, we'll just use it crooked. It's fine. All right, let's start with this one right here. I'm sorry, that's crooked. I don't know why it is. I must have locked it somehow. All right, to expand, I have to find a number. It's kind of like finding a common denominator. What's the common denominator with 6 and 3? Or no, I take that back. It's like cross-canceling. It's like simplifying a fraction almost. You have to divide them both by the same number. Well, I want to turn that. I know that 6 and 3 can both be divided by 3. So if I divide this by 3 and I divide this by 3, this would be 1. And 6 divided by 3 is 2m. And that would be my final. Oh. Take that back. Get rid of I put the parentheses here, and I would take that 3 and put it on the outside. Because look what happens if I distribute it again. That would be give me 6m plus 3. So to factor it, take out the 3, and inside the parentheses you're left with 2m plus 1. So what can we factor out of the next expression here, 10 and 2? I could take the 2 out. So let's take the 2 out. So that means divide this by 2, divide this by 2. 10p divided by 2 is 5p minus, and 2 divided by 2 is 1. And again, if I went back and redid it, that'd be 10p minus 2. So it goes back and forth. It could be interchangeable that way. All right, let's look at these two. 14 and 4. What can I factor out of 14 and 4? Well, 4 times something doesn't equal 14. So let's go with 2 because they're both even numbers. So let's take it factor a 2 out. So if I divide these by 2, this would be leaving with 2v plus, what's 14 divided by 2? 7. What can I factor out of 6 and 18? Well, 6, because 6 times 3 is 18, so I could factor out the 6. Take that out. Divide by 6. Wait, let me erase this here. Okay, so if I factor out the 6, I'll divide it by 6. That would give me 1 minus, and 18 divided by 6 is 3c. And again, if I wanted to check it, 6 times 1 is 6, minus 6 times 3 is 18c. So that would be kind of undoing our distribution there. Okay. 6, okay, this one says 6y minus 3 is equal to one of these, I think. We have to figure out which one it's equal to. Well, I mean, what we could do is I noticed that they all look pretty easy to solve, pretty easy numbers. So let's just think it through. Well, I'm just going to distribute these out. That would be 9y minus 3. Well, that doesn't match up, so this won't work. This one would be 6y minus 3. Does that one work? Yeah, that one definitely works. Let's just double check these to be safe. 6y minus 9. Does 6y minus 9 equal 6y minus 3? No, so that one doesn't work. And quickly, that would be 18 y minus 6, and that doesn't work either. Okay. Now, x is an unknown number. Write an expression for each of the following. This should be review for you from last year. Whenever you see more than, that means it's more than a number that you had to begin with. So that means you had a number to begin with, and you had 7 more than that number. So then you would go right plus 7. And whenever you see less than, see the key word is than, less than or more than. That means the numbers are going to come after the number that you started with. So 5 less than, and then it has twice the number. So twice the number would be like that, twice the number, and then 5 less than that will go there. We'll do more explanation on this too. All right, product means multiply. 8 and a number, so you would write that 8 times n, or 8x, either way. 8 times x. And here we have a more than again, more than, 3 more than half the number. So half of a number, and then 3 more than that, plus 3. So that would be your expression there. Simplify each of these expressions with decimals. Okay. So what I'm going to do on this problem, and this because I'm just kind of looking where I have to work at and how to show you, I'm going to put all my work in here, and I'm going to write my simplified expression underneath each value. All right, here we go. So, oops, sorry. Okay. So 0.5y can be combined with 2y. So 0.5 plus 0.2, just add those together. This will be 0.7y. Okay. This is really a 1x. So a 1x combined with a 0.6x. So 1.0, 0.6. I got to make sure I line up my decimals when I add. So this would be a 1.6x. This one, 0.7b plus 0.9. 0.7, 0.9. Line up the decimals, that's 16. So this would be 1.6b. I hate b's when they use that as variables because it looks like a 6 and it always confuses me. All right, here we go. 0.5k plus 1.6k. 0.5, 1.6. Line them up. 11, 2, 2.1. Okay, I'm going to rewrite that. That is sloppy. 2.1. Okay. Okay, let's look at these. I'm going to put my work over here. 0.2 plus 0.8, 0.2, 0.8, 10. This would be 1.0x, or even better, 1x, or even better, just 1x. I'm sorry, just x. That would be the final answer on that one. 0.4a, 1.2. 0.4, that's hard to see. 1.2, line up the decimals. 1.6a. 0.6m plus 0.8, 0.6, 0.8, 14, 1.4m, And last but not least, 0.8, 1.8, 0.8, 1.8, 16 to 2.6a. Okay, that's not taking too long. We're moving on. Okay, hey, that's a whole other page down there. Nice. Okay, let's move on to the next page. Last page. I'm so mad I did that crooked. I'm sorry, you guys. Ooh, some fractions. Okay, these ones, the top ones are easy, and I already noticed that because the first thing you can notice right away are they all have the same denominator, so that makes things really easy. Okay, so when you add fractions, you could put this x together with this x, and they have the same denominator, so you just add the numerators, 3/5 x. And then right here, 5/8 m plus 7/8 m, they have the same denominator. 5 plus 7 is 12. You could leave it like that, would be right, but we can simplify it even further. 8 goes into 12 one whole time with 4/8. And that could be simplified even further because the 4/8 can be reduced to 1 1/2 m. Okay, so that one had to do some simplifying. Okay. It's going to be 7 bottom. That's going to be 7 plus 2, or 3 plus 2 is 5p. And if you guys see mistakes as I go, that's fine. I make mistakes. I get it. Correct me. Let me know. Appreciate it. 9n, 7 plus 4, 11/9. That would be correct, but we need to simplify it further. 9 goes into 11 one whole time, 2 left over out of 9, and final answer. All right, now you knew it was coming. You knew you were going to have unlike denominators. So now I'm going to write these ones horizontally. Most of the time I like to work underneath my fractions when I find common denominators, but this time I'm going to go horizontally because of the space. Okay, so my common denominator here is going to be 6, because 3 I know goes into 6. And I could leave that 6 the same right there. I just have to turn this 3 into a 6. 3 times 2 is 6, 1 times 2 is 6, or is 2, so there I go. Now I have common denominators, and that would be 2 plus 1 is 3. There's my A. This would be correct, but I could still reduce it further. I could divide this by 3, divide this by 3, and get 1/2 A. And there's my more simplified expression. All right, here we go. Common denominator here is going to be 10. 7 tenths stay the same. 5 times 2 is 10, so 2 times 2 is 4. Add them up. 11/10 p. This would be correct, but I could also make it into an improper fraction. 10 goes in 11 one whole time with 1 left over out of 10p. Common denominator here with 4 and 3 is going to be, well, I can't use a 4 or a 3 because they both don't multiply or have factors that go into each other. So let's go with 12. 4 times 3 is 12. 1 times 3 is 3. 3 times 4 is 12, so 1 times 4 is 4. Now I can add them up. That give me 7 A's. Okay, these P's I'm going to put together. I have 5 and 4. The lowest common denominator for both of them is 20. 5 times 4 is 20, so 3 times 4 is 12. 4 times 5 is 20, 3 times 5, 15. 15 plus 12 is 27 20ths p. That would be correct. I could also say 20 goes into 27 one whole time with 7 left over out of p. All right, pretty good. We're almost done. Here we go. Let's put our k's together here. 2 and 8, common denominator will be 8. So this stays the same. 2 times 4 is 8, so 1 times 4 is 4. That equals 7/8. K, final answer. Common denominator here, 9. 9 will work. I always check to see if the larger one works. And in this case it does. So that stays the same. 3 times 3 is 9, so 2 times 3 is 6. That's 13/9 r. That will work, but I could simplify it further. 9 goes into 13 one whole time. 9, 10, 11, 12, 13, and 4/9 r. Okay, 2 and 5, the lowest common denominator, 10. 2 times 5 is 10, so 1 times 5 is 5. 5 times 2 is 10, so 2 times 2 is 4. So 5 plus 4 is 9/10 x. This one I could do up and down. I'm going to try it the other way because that's how I like to do these kind of problems. Okay, so 5 and 3, 15 is the common denominator. 5 times 3 is 15, so 4 times 3 is 12. 3 times 5 is 15, so 1 times 5 is 5. Add those up, 12 and 5, 17/15 y. That could be correct, but I could also make it into improper. 15 goes into 17 one whole time. 15, 16, 17, that's 2/15 y. All right, I think we did them all. I think we're done. All right, good luck. Don't just copy down the answers, though. Really think it out. I mean, you could do these. You really have to have a good foundation on these numbers that are not positive and negative values yet, because we're going to get into more and more of that. All right, good luck. Thanks. Bye.